All right, folks, it's Bass Action back in action here. On this page of notes, we're going to wrap up our sections 5.1 and 5.2, and we're going to look at evaluating our composite functions in terms of using a graph and using a table. We're also going to look at verifying functions algebraically. Our work with our tables and our graphs also can help us understand a little bit better how the domains work and how to work backwards on some of these. All right, so let's jump into our first examples here with our graph. So when I look at this first problem here with our graph, I'm asked to find f of g of 1. So these are pretty easy actually to break down. Students sometimes get confused with them, but they're actually pretty simple. We're going to start with this inside piece just as we've been doing all along. So we're going to find our g of 1 first. So we understand how to do that with our graph. We understand that this is the g function here. So I'm asked to find g of 1. I'm going to come over here to our x value of 1, go up to my g function, and I'm going to see that I get a 3. So g of 1 is 3. Then that answer will become the value that I'm going to evaluate my f function at. So now I'm going to find f of 3. So I can come to 3, an x value of 3, and now I'm going to go to my f function, that's the bold one, and that gets me a value of -2. And that right there is our final answer for that. So let's just try another one. We're going to start with finding g of -7, which means we're going to go over to -7, go to the g function. We're going to see that we get a 1. That then is going to tell us exactly what we need to do for our outer functions. So now we need to do f of 1. So keep in mind that's just taking this value and that becomes the inside piece there. So now we're going to go to our x value of 1. We're going to evaluate the f function at that, and it's actually right there at 0. So that one's all done. So that's all that we have to do. Now, working with our table, it really isn't that much different, except for we're going to be reading our values from a table instead of from a graph. So it's the exact same idea. So we're going to first find our f of -5, doing that inner piece first. So we're going to go to our x value of -5. The f function says it should be -3. So we're going to fill that in. That's going to tell us what to do for the outer function here. The outer function this time is a g, so we're going to find g of -3. So now I'm going to go to -3 and go to the g function, which is -11. And that's my final answer. Let's do one more here. We're going to first find our g of 0. So I'm going to go to 0, go to the g function, it's a 7. That's going to tell me that my next piece is going to evaluate at a 7. My outer function is an f function. So I'm going to find f of 7. So now I go to 7, to the f function is a 4. That's that final answer. All right, so that's working with our tables and our graphs. Now, the next thing that we're going to do, now that we've been practicing finding inverses algebraically, we're going to look at the idea of determining, or sometimes they'll say verifying algebraically if they're inverses. So a little bit on the language here. Typically speaking, if it says determine whether they're inverses, the answer might be yes, the answer might be no. If it asks to verify, typically they're telling you that they're implying usually that they are going to be inverses. Those aren't hard and fast rules, but they do, they're pretty common. Now, what we found when we were finding inverses is that normally when we found the inverse, it was something very different from each other. So the inverse of f was definitely the inverse of g. And then we also found that when we were doing our function composition, this was on the very first day, when we did f of g of x versus g of f of x, we found that typically those were very, very different answers from each other. When functions are inverses of each other, though, something interesting happens, and that function composition actually turns out to be the same. So if f and g are inverses of each other, then what you will find is that both f of g of x and g of f of x are both going to be x. So not only is the function composition the same in the direction that you do it, they both simplify to just an x. Not a 7, not a 3, not a 2x, specifically just an x. So if it asks you to show or verify that these are inverses, the first thing that you would do is that you would find your f of g of x. Now, we're verifying, so we know what our answer is supposed to be, so all of the work that we do is crucial. It's like doing a proof. So if we're going to find f of g of x, my outer function is f, so I'm going to have 1, left that on the highlighter there, sorry about that. I'm going to have 1 over, and I can see from my f function that I need to put this whole g function right here. So I'm going to color code that like I did in the previous video. So I'm going to have a 1 over x plus 1, and then I need to finish writing the f function that included this minus 1. So I'm going to have a minus 1 there. Now I'm going to start simplifying this. What I can see is that these 1's are going to cancel each other out. So then I'm left with 1 over x. And of course then if I have 1 divided by 1 over x, I can rewrite that with multiplication, and I can rewrite that as 1 over 1, that's my numerator, times the reciprocal of my denominator of x over 1, that of course simplifies to just an x, which is exactly what we wanted it to be. So now we're going to do our composition in the other direction. Our answer will be the same, but our work is going to look different. So this time I'm going to write my g function. So I'm going to have 1 over, and in the denominator this time I need to put this f function. So I'm going to write 1 over x minus 1. Now I'm going to finish writing the g function of my plus 1. Now there's nothing to really simplify on this first expression, so I'm going to go, instead of writing 1 divided by this fraction, I'm going to write 1 times this reciprocal. So I'm just going to, and of course 1 times that isn't going to change anything for me, so I'm just going to rewrite this then as x minus 1 over 1 plus my 1. Of course I don't need to write that fraction there, so I can rewrite that as x minus 1 plus 1. Of course those 1's then cancel out. X minus 1 plus 1 simplifies to just an x, which is exactly what we wanted it to be. So notice that our answers are the same, but the work that we have here on these two problems is dramatically different. If I was grading this problem, I'm mostly going to be looking at this work. So in terms of answering the question and understanding what's happening here, does f of g of x equal x? And our answer was yes. Does g of f of x equal x? And our answer was yes. And since they are both yes, okay, if it's yes to both, then they're inverses. If you get a no to either one of those, then they're not. And that's all that we have on this page of notes today.